It is a tangled up story indeed, Matt. There are some new developments in that other Tesla employees have now spoken to the SEC.
Potential trouble for Tesla, a government agency announcing that it will look into driver complaints.
Is Elon Musk hiding something about Tesla's self-driving technology? In a stunning turn of events, the tech mogul has made an unexpected admission about Nvidia's role in Tesla's autonomous driving capabilities.
You're my last thing.
Okay.
Okay, could you not ruin the whole thing?
This revelation challenges everything we thought we knew about Tesla's in-house technology and its relationship with other industry giants. The Nvidia-Tesla alliance in autonomous driving. In the fast-paced world of automotive innovation, one partnership stands out as a driving force behind the autonomous vehicle revolution: the alliance between Nvidia and Tesla. This collaboration has become the backbone of cutting-edge self-driving technology, merging Nvidia's expertise in artificial intelligence and computing with Tesla's groundbreaking electric vehicle designs. But what makes this partnership so special, and how is it reshaping the future of transportation? At its core, the Nvidia-Tesla partnership is about pushing the boundaries of what's possible in autonomous driving. Nvidia, long known for its graphics processing units that power high-end gaming experiences, has found a new calling in the world of self-driving cars. Their AI platforms are now the brains behind Tesla's autonomous vehicles, processing vast amounts of data from an array of sensors including cameras, radar, and ultrasonic devices. This data is then interpreted in real time, allowing the vehicle to make split-second decisions crucial for safe autonomous operation. Tesla, on the other hand, brings to the table its innovative approach to electric vehicle technology and its vision for a future dominated by self-driving cars. The company's ambitious goal of achieving full autonomy has been a driving force in the rapid advancement of autonomous driving technology. By leveraging Nvidia's robust AI hardware, Tesla has been able to continually enhance its autopilot and full self-driving features, bringing us closer to a world where human intervention in driving becomes optional. What does this mean for the average driver? Imagine a world where your car can navigate complex city streets, handle highway merges, and even park itself without any input from you. This isn't science fiction, it's the reality that Nvidia and Tesla are working towards. The collaboration has already resulted in significant advancements, such as Tesla's full self-driving computer, powered by Nvidia's hardware. This sophisticated system processes enormous amounts of data, enabling the car to make instantaneous decisions on the road. One of the most exciting aspects of this partnership is the potential for continuous improvement. Tesla's vehicles benefit from over-the-air updates, meaning that the autonomous driving capabilities of these cars can be enhanced even after they've left the factory. This approach to software updates, more common in smartphones than in traditional automobiles, is revolutionizing how we think about car ownership and maintenance. The impact of the Nvidia-Tesla alliance extends far beyond just making driving more convenient. At its heart, this partnership is about making our roads safer. Human error is a factor in the vast majority of traffic accidents, and autonomous driving technology has the potential to dramatically reduce these incidents. By removing human limitations like fatigue, distraction, and impaired judgment, self-driving cars powered by Nvidia and Tesla technology could save countless lives. Moreover, this collaboration is accelerating AI development across the board. The challenges of autonomous driving are pushing AI research to new heights, potentially leading to breakthroughs in various fields including healthcare, manufacturing, and robotics. The complex computations required for a car to safely navigate busy streets are driving innovations that could have far-reaching implications beyond the automotive industry. However, it's important to note that the road to fully autonomous vehicles is not without its obstacles. While the technology is advancing rapidly, there are still significant challenges to overcome. These include ensuring the technology's safety and reliability in all possible driving scenarios, navigating the complex regulatory landscape surrounding autonomous vehicles, and building public trust in self-driving technology. Despite these challenges, the pace of innovation driven by the Nvidia-Tesla partnership is truly remarkable. In just a few short years, we've gone from the concept of self-driving cars being a distant dream to having vehicles with advanced autonomous features on our roads today. As we look to the future, It's clear that the Nvidia-Tesla alliance will continue to play a crucial role in shaping the future of transportation. Their combined efforts are not just about creating self-driving cars, they're about reimagining mobility itself. From reducing traffic congestion to providing transportation options for those unable to drive, the potential benefits of this technology are vast and far-reaching. The partnership between Nvidia and Tesla exemplifies the transformative power of collaboration in technological advancement. By combining their expertise in AI and electric vehicles, they are not only shaping the future of transportation, but also paving the way for a safer, more sustainable, and more accessible world. As we stand on the brink of this automotive revolution, one question remains: how will the advancements in full self-driving technology change our daily lives and reshape our cities? The evolution of full self-driving technology. The answer, as it turns out, is nothing short of remarkable. Tesla's FSD system, powered by Nvidia's cutting-edge hardware, is pushing the boundaries of what we once thought possible in automotive technology. At the heart of Tesla's FSD capabilities lies Nvidia's high-performance GPUs. These aren't your average computer chips. They're computational powerhouses designed specifically for the immense demands of autonomous driving. The latest FSD computer, unveiled in April 2019 and now standard in all new Tesla vehicles, boasts an impressive 144 tera operations per second of neural network performance. This is a staggering 21 times more powerful than its predecessor, allowing for unprecedented levels of real-time data processing. So does all this processing power mean in practice? For starters, it allows Tesla vehicles to process up to 2,300 frames per second from various sensors, including 8 cameras, 12 ultrasonic sensors, and a forward-facing radar. This level of sensory input and processing is crucial for tasks such as object detection, lane keeping, and path planning, all essential components of autonomous driving. The FSD computer's capabilities go far beyond mere data processing. It employs advanced neural networks, a form of machine learning inspired by the human brain, to interpret this vast amount of data. These neural networks are trained on millions of real-world driving scenarios, allowing the system to recognize and respond to an incredibly wide range of situations it might encounter on the road. One of the most impressive features of Tesla's FSD system is its ability to improve over time. Through over-the-air updates, Tesla can continuously enhance the capabilities of its vehicles, even after they've left the factory. For instance, in October 2020, Tesla released its full self-driving beta to a select group of owners, showcasing advanced features like automatic navigation on city streets, including stopping for traffic lights and stop signs. But the advancements don't stop there. In August 2021, Tesla announced the development of its own AI chip, the D1, designed specifically for training its neural networks. This move towards vertical integration demonstrates Tesla's commitment to pushing the boundaries of FSD technology even further. The precision of Tesla's FSD system is truly remarkable. According to Tesla's 2020 vehicle safety report, drivers using autopilot, a precursor to full FSD, registered 1 accident for every 4.99 million miles driven. In comparison, the NHTSA's data shows that in the United States, there is an automobile crash every 484,000 miles. While it's important to note that these figures aren't directly comparable due to differences in how they're calculated, they do suggest a significant safety advantage for autonomous systems. However, it's crucial to understand that despite these impressive advancements, we're not quite at the level of full autonomy yet. The Society of Automotive Engineers defines 6 levels of driving automation, ranging from 0, fully manual, to 5, fully autonomous. As of 2023, Tesla's FSD system is generally considered to be at level 2, which requires active supervision from the driver. The jump to level 3, where the car can handle most situations but may need human intervention, and beyond to full autonomy, represents significant technical and regulatory challenges. One of the most fascinating aspects of FSD technology is its potential to revolutionize not just how we drive, but how we design our vehicles and even our cities. For instance, as cars become more autonomous, the need for certain safety features like airbags and crumple zones could potentially decrease. This could lead to lighter, more energy-efficient vehicles. Moreover, fully autonomous vehicles could change our entire approach to urban planning, potentially reducing the need for parking spaces in city centers and allowing for more pedestrian-friendly designs. The environmental implications of FSD technology are also worth considering. By optimizing routes and driving patterns, autonomous vehicles have the potential to significantly reduce fuel consumption and emissions. A study by the University of Michigan Transportation Research Institute suggests that self-driving cars could reduce fuel consumption by up to 10% in the short term, with even greater savings possible as the technology matures. Despite these exciting advancements, it's important to acknowledge the challenges that remain. One of the biggest hurdles is dealing with edge cases, unusual or unexpected situations that a self-driving car might encounter. These could range from complex weather conditions to unpredictable human behavior. Tesla and other companies are tackling this problem by continuously collecting and analyzing data from their fleet of vehicles, using each mile driven as an opportunity to improve their systems. Another significant challenge is public perception and trust. While the technology continues to improve, convincing the public to entrust their safety to an autonomous system is no small feat. This is where Tesla's approach of gradual feature rollout and constant improvement through over-the-air updates may prove advantageous, allowing users to slowly acclimate to increasingly advanced autonomous features. As we stand on the cusp of this automotive revolution, one thing is clear: the advancements in full self-driving technology are set to reshape our relationship with transportation in profound ways. From increased safety and efficiency to potential changes in urban design and environmental impact, the implications are far-reaching and exciting. Yet, as we marvel at these technological achievements, a crucial question arises. What are the broader implications of widespread autonomous vehicle adoption? And what challenges must we overcome to realize this vision? Challenges in the future of autonomous vehicles. As we stand on the precipice of a transportation revolution, the promise of autonomous vehicles beckons. What hurdles must we overcome to turn this vision into reality? And how will it reshape our world? The path to widespread autonomous vehicle adoption is as complex as it is exciting, fraught with technological, regulatory, and societal challenges that demand innovative solutions. One of the most pressing challenges facing autonomous vehicles is perfecting their ability to navigate complex and unpredictable real-world scenarios. While current systems excel in controlled environments, they still struggle with what the industry calls edge cases, rare, unexpected situations that require human-like reasoning to navigate safely. According to a 2021 study by the American Automobile Association, vehicles equipped with active driving assistance systems experience some type of issue every 8 miles on average. This highlights the significant work still needed to achieve true autonomy. Weather conditions present another formidable obstacle. Rain, snow, and fog can interfere with sensors and cameras, potentially compromising the vehicle's ability to perceive its environment accurately. A 2021 study published in the journal Nature found that heavy rain can reduce the accuracy of LiDAR sensors by up to 30%. Solving this problem is crucial, as autonomous vehicles must be able to operate safely in all weather conditions to be truly viable. But the challenges aren't just technical. The regulatory landscape for autonomous vehicles is complex and evolving. As of 2023, only 29 states in the U.S. have enacted legislation related to autonomous vehicles, according to the National Conference of State Legislatures. This patchwork of regulations creates uncertainty for manufacturers and could potentially slow adoption. Moreover, liability issues in the event of accidents involving autonomous vehicles remain a contentious topic. Who is responsible when a self-driving car crashes? The manufacturer, the software developer, or the owner? Public acceptance is another critical hurdle. A 2022 survey by the Pew Research Center found that only 39% of Americans think autonomous vehicles are a good idea for society. This skepticism is fueled by concerns about safety, privacy, and job displacement. Overcoming this will require not just technological advancements, but also public education and gradual exposure to increasingly autonomous features. Despite these challenges, the potential benefits of autonomous vehicles are too significant to ignore. Safety is perhaps the most compelling argument in their favor. The National Highway Traffic Safety Administration reports that 94% of serious crashes are due to human error. By removing human limitations like fatigue, distraction, and impaired judgment, autonomous vehicles have the potential to save countless lives. A study by the Insurance Institute for Highway Safety predicts that if all vehicles on U.S. roads were fully autonomous, up to 300,000 lives could be saved over a 10-year period. Beyond safety, autonomous vehicles promise to revolutionize mobility for those who cannot drive, including the elderly and disabled. According to the U.S. Census Bureau, there are approximately 40 million Americans with a disability that affects their ability to travel. Autonomous vehicles could provide unprecedented independence and access to transportation for this population. The environmental impact of widespread autonomous vehicle adoption is also promising. Through optimized routing, platooning, where vehicles travel close together to reduce air resistance and more efficient driving patterns, autonomous vehicles could significantly reduce fuel consumption and emissions. A study by the University of Michigan Transportation Research Institute suggests that these efficiencies could reduce fuel consumption by up to 10% in the short term, with potential for greater savings as the technology matures. As we look to the future, it's clear that the advent of autonomous vehicles will have far-reaching implications beyond just transportation. Urban planning, for instance, could undergo a radical transformation. With fully autonomous vehicles, the need for parking in city centers could be drastically reduced, as cars could drop off passengers and then park themselves in less premium locations. A study by the University of Toronto estimates that autonomous vehicles could reduce parking space needs by up to 87% in some areas, freeing up valuable urban real estate for other uses. The economic impact of autonomous vehicles is also projected to be substantial. A report by Intel and Strategy Analytics predicts that the passenger economy, the economic and societal value created by fully autonomous vehicles, could be worth $7 trillion by 2050. This includes new business models, reduced costs from improved safety, and productivity gains as people use travel time for work or leisure. However, this economic shift will not be without disruption. The trucking and taxi industries, which employ millions of people worldwide, could face significant job losses. A report by the UC Berkeley Labor Center estimates that autonomous vehicles could eliminate 300,000 jobs in the U.S. trucking industry alone. Mitigating this impact and ensuring a just transition for affected workers will be a crucial challenge in the coming decades. Privacy and cybersecurity represent another set of challenges that must be addressed. Autonomous vehicles will generate and process vast amounts of data about their passengers and surroundings. Ensuring this data is protected from breaches and misuse is paramount. A 2019 study by Georgia Tech researchers found that it's possible to use machine learning to infer a driver's identity and home address using just 20 minutes of driving data. As autonomous vehicles become more prevalent, robust data protection measures will be essential. The timeline for widespread autonomous vehicle adoption remains a subject of debate. While some optimistic projections in the past have not materialized, progress continues steadily. According to a report by Guidehouse Insights, annual sales of autonomous vehicles are expected to reach 14.6 million units globally by 2030. However, this represents only a fraction of the total vehicle market, indicating that the transition to a fully autonomous fleet will likely take several decades. As we progress towards this autonomous future, we're likely to see a gradual evolution rather than an overnight revolution. Features like advanced driver assistance systems will become increasingly common, paving the way for higher levels of autonomy. The SAE International's levels of driving automation provide a useful framework for understanding this progression. As of 2023, most advanced consumer vehicles are at level 2, partial automation, with some manufacturers pushing into level 3, conditional automation in limited scenarios. The role of infrastructure in supporting autonomous vehicles is another critical consideration. While most current systems rely primarily on onboard sensors and computing, there's growing interest in vehicle-to-everything communication. This would allow vehicles to communicate with each other and with infrastructure like traffic lights and road signs, potentially improving safety and efficiency. The U.S. Department of Transportation estimates that V2X technologies could address up to 80% of unimpaired vehicle crashes. Legal and ethical considerations will also play a crucial role in shaping the future of autonomous vehicles. Questions about how autonomous vehicles should behave in unavoidable accident scenarios often framed as modern versions of the trolley problem, remain contentious. A 2018 study published in Nature found that while people generally agree that autonomous vehicles should be programmed to minimize casualties, they're less comfortable with the idea of riding in such vehicles themselves. Resolving these ethical dilemmas in a way that satisfies both moral and practical considerations will be essential for public acceptance. As we navigate these challenges and opportunities, it's clear that the future of autonomous vehicles is not just about technology, but about reimagining our entire relationship with transportation and mobility. From urban planning to environmental impact, from economic shifts to ethical considerations, the ripple effects of this revolution will touch nearly every aspect of our lives. Yet as we contemplate this autonomous future, we must also consider its broader implications. How will the rise of autonomous vehicles intersect with other emerging technologies and societal trends? What role will artificial intelligence play in shaping not just our vehicles, but our entire transportation ecosystem? The AI revolution on wheels. As we navigate the rapidly evolving landscape of autonomous vehicles, one thing becomes increasingly clear. Artificial intelligence is not just a component of this transportation revolution. It's the driving force behind it. But how exactly is AI reshaping our roads, and what broader implications does this have for society at large? At its core, AI in autonomous vehicles is about perception, decision-making, and control. Advanced machine learning algorithms process vast amounts of data from an array of sensors, including cameras, LiDAR, radar, and ultrasonic sensors, to create a comprehensive understanding of the vehicle's environment. This real-time perception is crucial for safe navigation in complex dynamic environments. One company at the forefront of this AI revolution is Waymo, formerly the Google self-driving car project. Waymo's AI system, which they call the Waymo Driver, has driven over 20 billion miles in simulation and over 20 million miles on public roads as of 2022. This extensive experience has allowed their AI to encounter and learn from a wide variety of scenarios, making it increasingly adept at handling complex driving situations. The decision-making capabilities of AI in autonomous vehicles are particularly impressive. In fractions of a second, these systems must assess multiple factors: road conditions, traffic patterns, pedestrian movements, and more to make safe and efficient driving decisions. For instance, Mobileye, an Intel company, has developed a system called responsibility-sensitive safety that uses mathematical models to ensure autonomous vehicles make safe decisions in complex scenarios. But the impact of AI in transportation extends far beyond just controlling individual vehicles. AI is also being used to optimize traffic flow on a larger scale. In Pittsburgh, a system called SurTrack, developed by researchers at Carnegie Mellon University, uses AI to coordinate traffic lights across the city. This system has reduced travel times by 25% and wait times at intersections by 40%, demonstrating the potential for AI to alleviate congestion and improve urban mobility. The environmental implications of AI in transportation are also significant. By optimizing routes, reducing congestion, and enabling more efficient driving patterns, AI has the potential to significantly reduce fuel consumption and emissions. A study by the National Renewable Energy Laboratory suggests that widespread adoption of connected and automated vehicles could reduce energy consumption in the transportation sector by up to 60%, or increase it by up to 200%, depending on how the technology is implemented. This wide range underscores the importance of thoughtful policy and design in harnessing AI for environmental benefits. One of the most exciting aspects of AI in transportation is its potential to dramatically improve safety. The National Highway Traffic Safety Administration reports that 94% of serious crashes are due to human error. AI systems, which don't get distracted, tired, or impaired, have the potential to significantly reduce this number. For example, Tesla's autopilot system, when used properly, has been shown to reduce accident rates. According to Tesla's 2021 Vehicle Safety Report, there was one accident for every 4.31 million miles driven with autopilot engaged, compared to one accident every 1.59 million miles for non-autopilot vehicles. However, it's crucial to note that AI in autonomous vehicles is not without challenges. One major hurdle is ensuring that AI systems can handle edge cases, rare, unexpected situations that require human-like reasoning. To address this, companies like Cruise, a subsidiary of General Motors, are using a combination of real-world testing and advanced simulations. Cruise's simulation platform, which they call Continuous Learning Machine, allows them to test their AI against millions of scenarios, including rare edge cases that might occur only once in millions of miles of real-world driving. Another significant challenge is the black box nature of many AI algorithms. Deep learning systems, which power many autonomous driving AI, can be difficult to interpret, raising concerns about accountability and safety. To address this, researchers are working on explainable AI systems. For instance, MIT's Computer Science and Artificial Intelligence Laboratory has developed a system that can provide natural language explanations for autonomous vehicle decisions, potentially increasing transparency and trust in these systems. The intersection of AI and transportation also raises important ethical questions. How should an autonomous vehicle be programmed to respond in unavoidable accident scenarios? The famous trolley problem takes on new significance in the age of AI-driven cars. Companies and researchers are grappling with these questions. For example, Mercedes-Benz has stated that their autonomous vehicles will prioritize saving the lives of passengers, a stance that has sparked debate about the ethics of such programming decisions. Beyond safety and ethics, AI in transportation has far-reaching economic implications. A report by Intel predicts that the passenger economy, economic activity and value creation when drivers become passengers, could be worth $7 trillion by 2050. This includes new business models, productivity gains, and reduced costs from improved safety. However, this transition could also lead to job displacement, particularly in industries like trucking and taxi services. A report by the UC Berkeley Labor Center estimates that autonomous vehicles could eliminate 300,000 jobs in the U.S. trucking industry alone. The role of AI in transportation extends beyond just road vehicles. In the air, companies like Wisk Aero are developing autonomous electric aircraft for urban air mobility. Wisk's self-flying air taxi has completed over 1,500 test flights as of 2022, showcasing the potential for AI to revolutionize not just how we travel on roads, but how we move through three-dimensional space in urban environments. At sea, AI is also making waves. Yara Birkeland, the world's first fully electric and autonomous container ship, completed its maiden voyage in 2021. This vessel uses AI for navigation, docking, and loading-unloading operations, potentially heralding a new era of autonomous shipping that could reduce costs and environmental impact in the maritime industry. The impact of AI on transportation infrastructure is another area of significant development. Smart cities are leveraging AI to create more efficient and responsive transportation systems. For instance, the city of Los Angeles has implemented an AI-powered system called SAC, or Automated Traffic Surveillance and Control, that adjusts traffic signal timing in real time based on current traffic conditions. This system has reduced travel times by 12% and cut emissions by 10% in areas where it's deployed. Looking ahead, the convergence of AI with other emerging technologies promises to further transform transportation. The integration of AI with 5G networks, for example, could enable vehicle-to-everything communication, allowing cars to share information with each other and with infrastructure in real time. This could dramatically improve safety and efficiency. Similarly, the combination of AI with blockchain technology could create secure, decentralized systems for managing autonomous vehicle fleets and facilitating seamless, trustless transactions in transportation services. As we stand at the cusp of this AI-driven transportation revolution, it's clear that the changes ahead are not just technological, but societal. From reshaping our cities to redefining our concept of mobility, from transforming industries to challenging our ethical frameworks. The impact of AI in transportation will be profound and far-reaching. As we marvel at these advancements and contemplate their implications, we must also consider the broader questions they raise. How will we ensure that the benefits of AI-driven transportation are equitably distributed? What new skills and knowledge will be required in this new era of mobility? And perhaps most importantly, how can we harness the power of AI to create not just more efficient transportation systems, but more livable, sustainable, and inclusive communities? Don't forget to like this video and subscribe to the channel before you head out. Stay tuned for the next video. Thanks for watching.